Smart, smart, do. We are the children the children of God. Come, come, come. We change our world. We have what it takes to do it smart and make it smart. Welcome to our Smart Do.
Okay, class 6, welcome on board. We have a science lesson this evening. In our area of study is the weather and the sky. We are going to define these terms, or these are the areas we are going to cover. The first thing, if you look at the sky above you, there are objects you see in the sky, either during the day or during the night. During the night, you see stars, and you also see some dark clouds. During the day, you see the sun, you see the clouds, and the blue sky. And that's what I want to define today. In the sky, that's what we call the space. There are several things you get in the space. The first one is a planet, the other one is a meteor, the other one are stars. We also have the moon, we also have a meteorite, but the meteorite, you don't see it in the sky. You can't see all these in the sky. I want to start by defining what is a planet. Looking at the sky at night, you see some objects producing steady light. Steady light means they do not twinkle. One of them is a planet. The other one is a moon. Moon does not twinkle. Those are solid objects in the space. And the planets are stars, are like stars, only that they produce steady light. Then a star is a bright object in the sky at night that twinkles. This is what we call twinkling. Those objects are stars. The reason they twinkle because of one main reason. They have very high temperatures. Temperatures that can land this world. If that energy was to be tapped, the energy produced, like maybe the sun, one of the stars that produces heat. The heat makes the planets twinkle. We have energy from the sun, the heat energy from the sun. If tapped, the energy produced in one day, it can land the world for 1,000 years. And now, we have defined a planet as an object, a bright object in the sky that produces steady light. A star as a bright object in the sky that twinkles because of its temperature. The stars are billions, but our eyes can only see 3,000 at a go, 3,000 stars, but there are billions of stars. What makes the difference? The difference in the sizes of the stars depends on three things. If you have someone here, and this is their space. There is one star here, another one here. The color of the star or the twinkling of the star, the color depends, number one, with the distance from the earth. Number two, the size of the star. And number three, the temperature. There are three things that define the twinkling of a star. One, I've said, is the distance from the earth. Two is the size of the star, and number three is the temperature of the star. We go to meteorite. Meteorite are rocks that revolve in space. They are rocks that revolve in space. But don't worry, they are not going to fall soon. What I want to mean by that is, if this is the earth, there are rocks that are revolving up here. Someone is asking, why don't they fall? It's because our force of gravity, or the force that pulls objects toward the center of the earth, does not go beyond 80 kilometers of the earth. So gravity on earth can only be felt 80 kilometers. So anything beyond 80 kilometers cannot be pulled to the earth. Therefore, these rocks cannot fall because they are not pulled by the force of gravity to the earth. They just revolve here, but they are big rocks. They differ. Once these rocks happen to fall into the earth, because at times they miss the target and get into the earth atmosphere. Because this place is a vacuum, there is no air. The moment they get into the earth surface where there is air, there is friction between the matter and the air. So, because of that friction, they burn up, and you see them burning for a distance. At night, you see a steady light burning for around 75 to 100 kilometers. That is what we call a shooting star or a meteor. But those are burning rocks that revolve in the space. Artificial satellite. At night, you have also seen some objects moving, revolving in space, producing light, but still light of different colors, and moving at a very slow speed in space. Those objects are known as artificial satellites. Our scientists have managed to put some artificial satellites in space because of one reason. One, they revolve around the Earth to forecast the weather on Earth. That's why you hear in radio, they forecast weather. These are the satellites used to forecast weather. Number two, these artificial satellites are also able to search minerals on planet Earth. Number three, they are also used for communication. The moment you take your phone and make a call, you have to wait for your phone. If you are on this part of the Earth, your phone will connect to the artificial satellite next to you, then get to the other person. So they are used for communication. Artificial satellites have three main functions. One, they are used for searching of minerals, communication, and weather forecasting. Who is an astronomer? An astronomer is someone who studies all these. Anyone studying more about this is known as an astronomer. Someone who studies about the planets, the meters, the stars, and the moon is known as an astronomer. Now, what I want us to discuss finally is the solar system. The solar system is the sun and the planets. Because we don't only have one planet. The Earth is one of the planets, but we have several planets. All planets revolve around the sun, or they go around the sun on paths known as orbits. And they are egg-shaped. I will draw 8 of them because they are currently 8 planets. Up to 206, there were 9 planets up to 206 until when they discovered that the last planet, which was Pluto, was not a planet but a dwarf. A dwarf is a star that does not produce much heat. So there are several planets, there are 8 of them. I'll give the order from the first one to the sun. The one that is closest to the sun is known as Mercury. The other one is, then we have the Mercury as the one closest to the sun, Mercury. Then we have Venus, which is second. Then we have Earth. We have Mars. You have Jupiter. From Jupiter you have Saturn. And you have Uranus. These are the planets, 1, 2, 3, 4, 5, 6, 7. Neptune. Neptune is the last. And Neptune comes last. We have a slogan, we say, my very educated mother just shown us Neptune. Those are the planets in order, from the first to the last, as the distance from the sun. Mercury takes the shortest distance. Then I also want to say that planets differ in size. Some are larger than the others. The largest planet is Jupiter. Jupiter is the largest. Jupiter is the largest, and Mercury is the smallest. We have a slogan we can use to define the size of planets. We say, my mother visits Europe until next, and my mother visits Europe until next week, Saturday, June. This is Mercury, Mars, Venus, Earth, Uranus, Neptune, Saturn, Jupiter. This is the largest, this is the smallest. Thank you. In our next lesson, we'll be covering how to model the solar system.